Today in this video I'm going to talk about factorizing special expansions. So the first one I'm going to look at is the difference of two squares. If you've watched my videos on expanding, you'll know that we can expand a plus b multiplied by a minus b, and when we expand that, what happens is it simplifies to be a squared minus b squared. What we have here is two squares and we have the difference between them. So what we're looking at in this video is, can we identify an expression that is the difference of two squares and be able to factorize it back to what this looks like, so into two brackets. So let's have a look at x squared minus 25. And what I like to do is I like to have the rule here. So you are looking purely for, do I have two terms? It's quadratic. I've got two terms. And I can see that this is squared and 25 is a squared number, and I'm finding the difference between them. So what I need to do is say, well, okay, if a squared has to equal x squared, we let a equal x in this case. And if b squared equals 25, then we can say that b is 5, or the square root of 25, which is 5. Now I simply substitute these values into this and I factorize this expression. So x squared minus 25 factorized becomes x plus 5 multiplied by x minus 5. And this, you'll know from special expansions, is the difference of two squares. It's a special expansion. Let's do some more complicated ones. I'll do a couple, one more easy one and then I'll do another complicated one. So again, let's suppose I need to factorize, and so I'll just keep this up here. If I'm going to factorize, so let's go with x squared, I'll keep it under here, x squared minus 100. Again, what I'm looking at is it's two terms. It's a quadratic, it's only two terms. This is squared, 100 is a square number. I've got the difference between them. So I need to say, okay, this is the rule for the difference of two squares. Let's have a look at what a is. This would be a squared minus b squared, and we know that that's going to factorize to be a plus b multiplied by a minus b. Looking at this, well, x squared has to equal a squared, so therefore, again, a is equal to x. And b squared has to equal 100. So b is the square root of 100, which is 10. So b is 10. So fully factorized, this becomes x plus 10 multiplied by x minus 10. Now, what about if you've got some coefficients of expressions, but it looks like it's going to be a difference of two squares expression. So what I mean by that is 64, let's do one down here, 64m squared minus 25n squared. Okay, well, looking at that, the first thing you need to ask yourself is, do they have any common factors? No. Then you need to say, okay, 64 is a square number, m is squared. 25 is a square number, n is squared. There's the difference between them. That's what the takeaway sign means. I'm looking at the difference of two squares. So we know from our rule here, a squared has to equal 64m squared. So we think to ourselves, okay, if I square root this, 64 square root is 8, m squared square root is m. So if I now write that that is 8m all squared, that gives me 64m squared. Same with this one. 25n squared, I can square root that, I get 5n, and if I show that that's all squared, I get back to this. Now what I've done here is I've shown that this is now your a squared, sorry, this is a squared, and this is b squared. So a is 8m, and b is 5n. Again, we know that this goes to this, so fully factorized, we can just simply write 8m plus 5n multiplied by 8m minus 5n. Okay, I'm going to clear some space. Let's look at another special expansion. You'll remember the perfect square, which can potentially have a takeaway sign there, but let's just look at the positive one for now. A plus b all squared expands to be a squared plus 2ab plus b squared. So let's have a look at what happens when we've got a quadratic expression, looks like it's in this form. How can we factorize it so it's back in this form? So for example, let's suppose I've got to factorize x squared plus 6x plus 9. Well, I look at that and I think, okay, it's got an a squared here, which is x squared, I can see that the square root of 9 is 3, and this is twice 3. So I'm looking here at a perfect square. So what I'm going to do is I'm going to go, okay, this is A, or A is x, and B in this case is the square root of 9, which is 3. Putting that back in, this fully factorized becomes x plus 3 all squared. What about if I do, let's do a trickier one up here. Let's do one that's a bit trickier. We've got factorize, so another example. We're going to factorize 2x squared plus 24x plus 72. Okay, it's quadratic, I noticed that. But I also spot that each of the three terms has a common factor. So the first thing I'm going to do is pull out the common factor. Makes it, see if I can then make it easier to factorize. Well, each of these go into 2. So if I pull out 2, I'm left with so. And I also identify that 36 and x squared, they're both squares. And in fact, the square root of 36 is 6, and 12 is twice 36, according to the rule for the perfect square. So I can say that A is equal to x, and B must be equal to 6. The only times you have to, and of course I can now write that as x plus 6 all squared. And that's what that factorizes. Oh, my mistake, there's a 2 in front because I had the 2, I pulled the 2 out as the factor in the first place. Not forgetting that. The only time where you have to be careful is expressions where there's a takeaway sign, and you might have the takeaway sign here, but this would still be positive. Let's do one of those. So I've written here, you can see I've changed that to the takeaway. So let's have a look at this. Again, it looks like it's going to be a quadratic, however, there's a common factor. All of these go into 3. So I'm going to pull out 3 as the common factor first to see what I'm left with. And then I'm going to look at this and I'm going to say, okay, this is square. This 16 is a square number. Y is squared. So it looks like I've got A squared and B squared. But let's double check. Is the square root of this, well, let's just actually, that should be positive. Sorry, that's not going to work otherwise. Sorry, let me start again. Is the square root of 16, is this going to be 4, 4y? Let's have a look. It can't be 4y because I've got a negative here, so it must be negative 4y. Let's have a look. If A is x and B is negative 4y, I get back to negative 8xy. So it is the perfect square. So that I can now simply factorize this, knowing that I've said that A is equal to x and B is equal to negative 4y. When I pop it in here, don't forget the 3 on the outside. I just pop in here, we get x minus 4y all squared. And that pretty much is everything you need to know about factorizing special expressions.